Hey everybody, this is another video over solving three variable systems of equations. I figured it would be helpful if you had a couple more problems worked through, so I chose two problems from your three variable system practice to just talk through here. So remember, we're trying to decide, first of all, which variable we think was going to be easiest to cancel out first. Here, I think it's probably going to be the y's. Okay, because I can really easily cancel out the y's in this set of equations. Okay, and then we can cancel out the y's pretty easily with these two equations as well. And this isn't the only way to approach it, but this is what I'm going to do. So for A, okay, we're going to, let's see, we need to cancel these y's out. So in A, I'm going to multiply the middle equation by a -1. So we get a negative y, and then we have a positive y in that bottom equation. And then for B, let's see. We want to make that middle equation have a positive 6y. So let's multiply that middle equation by a positive 6. Okay, so let's go ahead and get this set up. So let's do A. Okay, for A, we've got, let's see, we said we were going to multiply that middle equation by -1. So we have -5x minus y minus 2z equals -10. Okay, and then the bottom equation there, we didn't change anything. Okay, so let's see, we're going to add these together now. So -5x plus 3x gives us a -2x. The y's cancel. We add the z's. We add our numbers here. Okay, so we've got an equation with just x and z left. So now let's do B to get another equation like that. And let's see, for B, we said that we're going to multiply that middle equation by 6. So my top equation isn't changing at all. I multiply my middle equation by 6 to get 30x plus 6y plus 12z equal to 60. And then we're going to add to cancel the y's again. So we get 32x, y's cancel, plus 21z equal to 52. Now, remember, the point of this is to be able to create a two-variable system. Okay, in this case, our two-variable system is going to be made up of this A and B equation that we just found. And then we're going to have a two-variable system with just x and z left. And then it's just algebra 1. All right, we've got a two-variable system, and we're going to do elimination one more time to actually be able to solve. So let's see here. We need to stack our equations. Okay, but we also need to decide which variable we're going to cancel out next. So we're trying to decide what's going to be easiest. Is it going to be easier to cancel the x's or the z's? And in my, from my perspective, in my opinion, I think it's going to be easier to cancel the x's. I think it'll be easier to try to make this a -32x so that we can just add the equations together and cancel the x's out. So we're going to multiply this A equation by 16 when we go ahead and rewrite this new system. Okay, so let's go ahead. Let's write our new system. Okay, we said we're going to multiply A by 16, so we get -32x minus 160z. Okay, and let's see, -38 times 16 gives us -608. And then our B equation, we're not changing at all. We've already got that 32x there. So now we're in a position where we're ready to add these equations together. The x's are going to cancel. We get a -139z equal to, let's see here, negative 608 plus 52 is going to give us negative 556. So now when we divide, we get z is equal to 4. So now we can start plugging back in to find the rest of our answers here, okay, to find the rest of our x and y values. So we're going to find x next. Okay, so let's plug back into our a equation. So we've got negative 2x minus 40 equals negative 38. So let's see, we need to add 40 to both sides, divide by negative 2, so we get negative 1 as our x value. And then we're going to go back and find y now. So let's see, let's pick one of our original 2 equations, or original 3 equations, I should say. We're looking for y. Let's plug back into that middle equation. So 5x, so 5 times negative 1 plus y, and then let's see what it was for z. I can't remember here. Plus 2z is equal to 10. So plus 2z is equal to 10. So we get negative 5 plus y plus 8 equals 10. So let's see, we really have y plus 3 equals 10. So we get y equals 7. So all together now, our solution is negative 1, 7, 4. So let's look at one more system here. Okay, again, we have to decide, what do we think is going to be easiest to cancel? And in this case, I think it's going to be the z's. Okay, I can cancel the z's out in this equation pretty easily if I multiply the middle equation by 8. And I'm going to do the middle and the bottom equations here for b, and we're going to multiply the middle equation by 4. Okay, that way we get a negative 4z in that middle equation. So let's go ahead and set these up. So let's see, a is going to be 5x minus 3y plus 8z, and that's equal to negative 59. Okay, and then we said we're going to multiply that middle equation by 8, so we're going to get 72x minus 32y minus 8z equals negative 480. And we're going to add these 2 equations together. So we get 77x minus 35y equal to, let's see here, negative 480 plus a negative 59. We're going to get negative 539. So now let's set up our b equation here. We've got, what was it? We said the middle equation was going to get multiplied by 4. So we've got a 36x. Sorry for the interruption there. So we've got 36x minus 16y minus 4z equal to negative 240 now. And then that bottom equation isn't changing. So we just got to add them together. We get 41x minus 12. Oh, I can't add together. Minus 14 y. The z's cancel, and that's equal to negative 287. So now we have to decide, okay, what am I going to cancel next? And I think it's probably going to be easiest to cancel out the y's. What I'm going to do is, to create a common coefficient, I'm going to multiply the a equation by a negative 14. So what that's going to do is it's going to create a coefficient of 490 in front of my y. And then to get it to match over here in the b equation, I'm going to multiply by 35 so that I get a negative 490. So we're going to have some big numbers, but it's okay. I mean, we've got calculators. We can handle it. It's going to be fine. So let's write our new system. So the a equation, we said we're multiplying by a negative 14. So we get negative 1078x plus 490y. And that's going to be equal to a positive 7,546. Okay, our b equation is getting multiplied by 35. So we get 1,435x minus 490y. And that's going to be equal to a negative 10,045. So now we can add these equations together. Our y's are going to cancel out. So let's see what we've got for the x's here. We're going to have a 357x equal to, let's see, big numbers here, negative 2,499. So if we divide by 357, we find that x is equal to negative 7. So now we start backtracking to find the rest. So if we back up to our a and b equations, where we just had x and y, okay, we can plug in this x value we just found to find our y value. So let's see, let's plug it into our b equation. So we've got 41x minus 14y equal to negative 287. So that'll give us negative 287 minus 14y equals negative 287. So if we add 287 to both sides, we get y equal to 0. So now we've got x, we've got y. It's just time to find z now. Okay, so if we're going to find z, we need to plug these x and y values back into one of our original three equations. Let's do that middle equation, okay, that 9x minus 4y minus z. So let's see, we've got 9 times x minus 4 times y minus z, and that's supposed to be equal to negative 60. Okay, so we've got negative 63 minus z equals negative 60. So we add 63 to both sides. We find that z is equal to negative 3. Okay, and with each of these problems, remember, we're supposed to be writing our solution as an ordered triple. So here we go. All right, so that is it for this video. Hopefully you found. Let me know if you have any questions, and have a wonderful rest of your day.